In the early days of aviation, they used the materials that they had available at that time in the early 1900s to build aircraft. That meant a lot of wood, cotton, things that you would expect to see inside of old buildings that you would see at museums or historic sites. That's where aviation was born, and they simply just leveraged the assets they had available to them at that time. That meant that most all of the aircraft, at that time, all the aircraft consisted of a lattice work with some sort of covering over the top of it. And today, we're going to talk about that covering. Now, those coverings still today get used all the time. It's not aircraft grade cotton like it used to be anymore. That's kind of gone extinct. Nowadays, they'll use other means and methods to cover an aircraft, and it offers some pretty distinct advantages. It's super lightweight. It's relatively easy to manipulate and to work with. It's repairable. It doesn't corrode, and it doesn't rot. And so, like, a lot of the fabric covered wings today are far superior than some of the aluminum covered wings today in a lot of ways. Now, it has its limitations and it has its drawbacks, just like everything. And so, we're going to talk about what it means to cover a wing, what materials do we use, how do we inspect them, where can we find them, and then what does that mean for you? Now, aircraft started off covered in cotton fabric. That's what the Wright Flyer used, and that became the standard immediately. And everybody everywhere was doing it. But the more aircraft were built, and the more environments that they flew in, the faster they went, they started encountering all kinds of problems with this technique. First off, they noticed that it was sagging. Just over time, cotton, like any sort of organic material, will absorb water, and that water will start to cause it to sag. And so you're constantly having to maintain the airplane and try to keep it tight. And so they were like, maybe there's a different way to do this. So they put a thing on called nitrate dope, and those were the first dope that anytime you dope a wing, you're taking a chemical and then applying it to that wing. That was the first time it had ever happened. Well, they solved a lot of problems, but they created a whole new one. Is that the dope, whenever it's on, is extremely flammable, and so aircraft engineers kind of went back to the drawing board and was like, okay, there has to be a dope that isn't as flammable as nitrate dope, and so they switched to another type called butyric acid. They put that on. Well, while that solved the flammability issue, it just didn't adhere as well to the wing, so then it starts to flake off and cause all kinds of different problems. So your aircraft engineers come together and they start mixing and matching, and they eventually get a solution going, and that solved those problems. But then it added a whole new problem, which was the durability. Specifically, the deterioration caused by ultraviolet light. So ultraviolet radiation passed through the dope and degraded not only the fabric but the structures underneath. So just if you take an old boat and you set it out in the sun summer after summer, eventually the clear coat starts to break down. The aircraft were having the same way. And keep in mind that this was before the era that there were hangars all over the place to put aircraft in, and so there was a lot of them that just kind of sat out on the fly line, and then they started realizing, hey, look, this isn't working out because our aircraft is slowly breaking down. And so eventually aluminum solids were added to the coatings, and the mixture reflected the sun's rays and helped prevent some of the harmful UV rays from penetrating the dope, help protect the fabric, and therefore the aircraft structure. But regardless of the treatment, doesn't matter what you did to it, they only have a lifespan about 5 to 10 years. And so it just didn't, every 5 to 10 years you're having to recover not just a part of the airplane but the entire airplane. And so you can imagine how cumbersome that got and how expensive it got. So people started to realize, man, there's got to be a better way. And so even today, modern aircraft grade cotton like that, it's just not available and hasn't been available for almost 3 decades now or more. So as the aviation industry developed more and more powerful engines as well, like the stress on the airframe became just great. I mean, can you imagine putting a jet engine on a fabric covered airplane? It would just rip it apart. So that's where you start getting aluminum and composite aircraft start to come on the scene. However, although aluminum composite aircraft dominate modern aviation, advances in fabric coverings continue to be made because gliders, home built, and light sport aircraft, as well as some standard and utility certificate aircraft, are still produced with fabric coverings. Now, you think just a couple off the top of my head, like Piper Super Cubs, Aviate Huskies. Those are just two examples, just off the top of my head, of aircraft that are out there. There is a guy that will fly in and out of here that has a Cessna 120. That 120 has fabric wings, just like the Cessna 120 that we have on the hangar floor. So knowing how to address the issues that come around aircraft fabric is really, really important, because you're going to encounter it if you work in the general aviation world. Now, if you go in commercial, you're not going to see these kinds of wings and structures, but it's still good for you to know, because you never know how this information may come in handy in the future. Now, so whenever you go to attach this fabric, um, there's a couple things that we need to get out of the way right off the top. So before any fabric is attached, it needs to receive a final inspection by an A&P with an IA to make sure that the covering that's going on to an airplane it's ready for it. Like that the substructure is not broken, especially if you're restoring like an old wooden airplane. Then they need to look for dry rot or rot just in general, and all the problems that you may end up incurring with a wooden airplane. Now, the other thing to say is that like now all the different techniques that we're going to go over, and all of the different types of fabric we're gonna go over here in the next few minutes. It's good information for you to know, to be familiar with. But whatever you're working with, follow the STC, or follow the AMM that you're working towards. Reason being is that like these are all unique to the aircraft that they're going into. They might share some commonalities with other airplanes, but effectively the way that it's attached and the way that you're going to maintain it and work on it needs to be done per that maintenance manual or that approved data. Okay, now that we have a kind of a cursory understanding of wing coverings, let's talk about the different textile terms, because they're unique, and they're unique to this part of aviation. You won't see them elsewhere. So let's talk about that and get a good understanding of that vocabulary, so that way we can use it going forward. Okay, so the first term that we need to talk about is warp. That's the direction along the length of the fabric. So the warp goes from top to bottom, the long end of the fabric. Next is weave or fill, or in this case, they're going to use a weft, but it's the same idea. It's the direction across the width of the fabric. So warp goes from top to bottom. Weft, weave, or fill goes left to right. Now, some like infographics and information that you'll come across, they'll talk about weave as a pattern. So like you'll have like a plain weave or a different type of weave that'll be on there. They're talking about, if you think about like an old loom, the warp goes from top to bottom, and then the weave is the shuttle that goes from from your left to right or whatever. And the different types of weave, or the different techniques that are employed in the weaving of the warp strings. So that's fill, warp, or fill, weave, or weft. Okay, the next one we need to talk about is count. That's the number of threads per inch in a warp or filling. So it means that like if you take one square inch, how many runs of fabric are you to get through there? Now, this is something you should be familiar with if you ever go with like your wife, girlfriend, or maybe yourself to Bed Bath and Beyond, and they're all about the 4,000 Egyptian cotton count sheets, because they're the softest and the slickest, or somehow the best sheet to put on the bed. So you'll understand the higher the count is, the higher quality the fabric is. So that being said, that is a fabric count. All right, next is plies. So a ply is the number of yarns making up a single thread. So there on the picture, there's a 1 ply yarn. It just means there's just like one piece of yarn that's been spooled together to make a string, and then 4 ply yarns. That's 4 different pieces of yarn that's been twisted together and then run. And in this case, they've been twisted again to make a piece of yarn. So like think of your individual, like, pieces of rope inside of a yoke. Rope are the different plies of the fabric. Okay, next is a bias. It's a cut, fold, or seam made diagonally to the warp or fill threads. Now, this is actually going to be kind of important when we get into composites. Because like you're going to end up having these different degrees, and you'll see that like there's like going to be a 45-degree layup or a 90-degree or so on and so forth, whatever degree that the job calls for. Effectively, it's the same thing. The bias is going to be that cross line across the length and the cross grains or the weaves. Okay, a pinked edge is an edge which has been cut by a machine or special pinking shears in a continuous series of V's to prevent raveling. So this is another thing that you'll see in composites later on as well, that like you want to pink the the edge of the fabric to keep it from coming apart. But that's what it looks like. It makes those little like jigsaw teeth, kind of like saw teeth in the fabric. You've seen them before because this actually gets used all over the place. If you start paying attention to it, you'll see pinking all over the place. Okay, next is a selvage edge, the edge of cloth, tape, or webbing woven to prevent raveling. That's what a selvage edge looks like. It's simply just been woven so that way it won't come unraveled. It's kind of like pinking, but it's just a different technique. A little bit superior technique in my estimation. Okay, last term is a cross coat. It's a brushing or spraying where the second coat is applied 90 degrees to the direction of the first coat that was applied. The two coats together make a single cross coat. And you remember seeing that guy in the little black and white film that we watched at the very beginning. He was actually doing a cross coat at one point. Now, just like everything, there are approved materials, and there are some materials that aren't approved for work on aircraft. Let's talk about the approved textiles that we can use to cover an aircraft wing and how they're different. Okay, so before we get going, let's say a technical standard order is the minimum performance standard issued by the FAA for any specified materials, parts, processes, appliances, you name it, on an aircraft. So TSO Charlie 15D is aircraft fabric grade A, prescribes the minimum performance standards for the approved aircraft fabric must be met. So the ones that you're looking at right here, so C-Sonite 101 and 102, polyfiber, there are 3 variants, and Superflight and grade A cotton all meet TSO Charlie 15D. Now, that TSO refers to another document in the Society of Automotive Engineers, or SAE. It details the properties of the fabric that have to have in order to be an approved fabric for airplane cloth. The lighter weight fabrics typically adhere to the specifications TSO 14B, which also refers to a whole other SAE document. So when a company is approved to manufacture or sell an approved aviation fabric, it applies for a PMA. Now currently, only a few approved fabrics are used for aircraft covering, such as the ones that you see in front of you, that C-Sonite, polyfiber, and Superflight. Now these fabrics and some of their characteristics are shown here, and the holders of the PMA for these fabrics have also developed and gained approval for various tapes, cords, threads, liquids, all the accoutrements that go with it. Now these approved materials, along with the procedures for using them, constitute STCs for each particular fabric covering process, which goes back to what we were talking about earlier. Make sure you follow the STC, the approved data, all that good stuff, because they're all a little bit different. Only the approved materials can be used, which is another thing. Is that like you can't just put any old tape on any old fabric. They have to go together. Substitution of other materials is forbidden, and the results in the aircraft being unairworthy because you never know the thing might come apart on you if you're flying it. Now, some examples of the type of extra materials that need to make sure that they're used with the correct fabric is anti-chafe tape and reinforcing tape. Now, anti-chafe tape is kind of in the name; it just keeps things from that are sharp from protruding, and messing up like rib caps, metal seams, other areas that need to have a smooth surface to keep the fabric from being torn. The reinforcing tape is commonly used on rib caps after the fabric covering is installed to protect and strengthen the area attaching the fabric to the ribs. Now, in front of you is a graphic that outlines another type of material, and that's rib bracing tape. It's used on wing ribs before the fabric is installed. It's applied span-wise and alternately wrapped around the top rib cap and the bottom rib cap, progressing from rib to rib until they're all braced. Now, lacing the ribs together in this manner holds them in the proper place and helps them during the alignment during the covering process. It's fairly important. However, because it still touches the final fabric that's being installed, it has to be compatible with it. Last tape is a surface tape, which is made of polyester material and often pre-shrunk and is obtained by the STC holder. This tape, also known as finishing tape, is applied after the fabric is installed. It's used over seams, ribs, patches, edges. Surface tape can have straight or pinked edges and comes in various widths. For curved surfaces, bias cut tape is available, which allows for the tape to be used around a sharp radius. All right, let's talk about the methodology of actually covering the wing and how they're different, and when do we use one versus the other, and what are the strengths and weaknesses of these different methodologies. Now, when I was a kid, a friend of mine grabbed me at school one day and said, "Hey, I know a guy that's building an airplane," and I said, "Okay, well, let's go check him out." So we go out to this house that has this long runway with a barn on the end of it, and we knock on the door, and a little old man opened up the door and kind of like ushered us in and showed us the airplane that he was building. And what he was doing is he was fabric wrapping wings for this ultralight that he was putting together, and then ironing it on just like the picture you see here. Now, this isn't that guy, but that's exactly what he was doing. He would wrap the fabric on there, warm up the fabric, and what it would do is it would turn from being this like polyester like material to being hard enough to where you could have sworn it was metal whenever you touched it. And I remember being just completely enamored with this whole process because it was totally alien to me. It went from being what felt like a piece of my t-shirt to all of a sudden being really hard and shiny, and it looked like it was a piece of metal. And so that's one technique to covering aircraft wings, is that you can actually iron on the fabric. You can also sew it on. There's about a couple of different ways that you could do it. Now, with modern aircraft materials, you're kind of limited to whatever the STC calls for. So the material that you're using that is on that table that we just looked at, either Seasonite, Polyfiber, or Superflight, they're all STC approved fabrics with processes used to install that polyester fabric covering. So it means that you have to follow their instructions to do it correctly, or else the aircraft is unworthy. So although you can get grade A cotton, or like you used to be able to at least, it can be used on all aircraft originally certificated to be covered with that material. The approved aircraft cotton fabric is just not out there anymore. You're not gonna be able to find it. So like if you had it and you were able to prove that it was built when and was certificated to be used on aircraft, then sure, you could put it on there and sew it up. But nowadays that just doesn't exist anymore. So you're relegated to doing a polyester fabric covering with an iron, just like this old guy. No matter what material that you end up using, you're going to have to remove the old fabric. You're going to get it out of the way. And so removal of the old covering is the first step in replacing the aircraft covering. You cut away the old fabric from the airframe with a razor blade or a utility knife, just like you'd expect that you would. Care should be taken not to ensure that damage is done to the airframe. Use the old covering for templates and transferring the location to the inspection panels, cable guides, and other features using the new covering. So you think about it, if you were to peel the skin of an aircraft off, the first thing that you're going to see is that, hey, look, there's all kinds of these little access panels all over the aircraft, and you're going to want to make sure that you use those old coverings as templates about where the new access panels should go. Now, there's two methods for recovering an aircraft. You can either use the blanket method of recovering an aircraft, like you see here in this picture, where they're going to drape it over there and then seal it up, or you can use the envelope method. Which is it saves time by using pre-cut and pre-sewn envelopes of fabric to cover up the aircraft. So essentially, you're going to slide like a little sleeve over the wing, as opposed to like throwing a blanket over there and having to mess with it. Now, before we actually go to attaching anything, we need to make sure that the airframe is inspected, like we talked about before. Clean everything thoroughly with MEK or some sort of cleaner like that, and then tape up any sharp edges, metal seams, heads of rivets, anything that can poke a hole and cause the aircraft or cause the fabric to tear. And then at that point, you're ready to start attaching the fabric based on whatever STC or that you're working towards. But yeah, that's no matter which fabric you go with, no matter what STC you're working. Effectively, that's kind of the process that you're going to go through. You're always going to remove old fabric, clean it off, tape it up, have it inspected, blanket or envelope seal on top of it, and then attach per the document that you're working towards. All right, just like there's like lap joints with rivets or welds and other things that we haven't got to yet with composites, there are certain types of seams that can be used with fabric coverings. Let's talk about the differences in those seams and how we tell them apart, and then how we maintain them as aircraft mechanics. Okay, so most covering procedures for polyester fabric rely solely on doped or glued seams as opposed to sewn seams. They're simple and easy to make, and they provide excellent strength, elasticity, durability, and appearance. So when using the blanket method, seams overlap is specified in the covering instructions, and the mechanic has to adhere to those specifications. So, but typically, a minimum of 2 to 4 inches of fabric overlap seems to be required where the ends of the fabric are joined in areas of critical airflow, such as the leading edge of the wing. 1 or 2 inches of overlap is often the minimum in other areas. However, if you find yourself doing sewn seams, then there's a couple of different seams that we can use. Now, here we're just going to kind of go in order from A to E, and we're just talk a little bit about these different seams. So the first one, top of that, is very much like a lap joint. It's just the plain overlaps seam with the straight edge. All right. That's pretty simple. You take the two pieces of fabric, lay them on top of each other, and sew on two different sides, forming the most simplest of seams. Now the French seam is very similar. The difference is the fold that goes to the middle, making it a little bit thicker. Now you can have a folded fill seam, which effectively what you have is like an overlap seam that's come in, but they folded the two ends so that way they're pointed toward each other on the inside, and then you sew down those folds. That gives you a folded fell seam. Now, a modified folded fell seam basically is the same thing, but only halfway there. So instead of having both ends of the fabric folded in and pointed towards each other, one is folded pointed towards each other, the other one just lays flat. Then, like the single stitch seam, close an envelope when the stitch will be located over structure. So this happens only whenever structure's involved. So essentially, like you'll sew up, and then you'll sew the two pieces of cloth together, and then lay them 90 degrees opposed to each other, so that way they can wrap around whatever it is that they're going onto. But that's a single stitch seam. All right, now once the seam has been made, it's very common to dope the seam. So you're gonna go over the top of it with some dope to help seal it up. That's what these women are doing here on this old airplane. And that overlap dope span-wise seam at the trailing edge and lap the fabric at least 3 inches and cover it with a pinked edge surface tape at least 4 inches wide, with the tape centered on the outside edge of the overlap seam. So just because you've sewn a seam and you've doped a seam doesn't mean that's enough. Oftentimes you're going to have tape that goes over the top of that, and that's usually what you're going to end up really inspecting is make sure that tape's still adhering to the seam. Every different type of seam at different places will have different requirements because of the different structural stress and the different types of environmental factors that have been subjected to that seam. And so you want to follow the STC to the letter to make sure that you have it right. Now, on polyester fabric, a lot of times it gets cemented or glued to the airframe structure at all points where it makes contact. So special formula adhesives have replaced the nitrate dope for adhesion in most of the covering process. So remember, like with a sewn seam, you're going to sew it, tape it, dope it, and then go on about your day. With polyester fabrics, you simply you're going to glue them together, and then you're going to glue the fabric to the airframe itself. Now, once you attach it to the airplane, you put some adhesive on there. You're going to stretch the fabric over there and let it adhere. Once it's adhere with whatever adhesive your STC calls for, then you're going to take the iron out and start heat shrinking it. Now, every STC is going to have its own kind of approach to the right way to heat shrink, or how to apply the heat to your fabric to help it tighten up. But essentially, this is the way that they'll all kind of follow the same pattern. You'll begin on one end, moving the iron in 180 degree alternating pattern, so that you're kind of back and forth and moving around, just like you would like kind of iron a shirt. And then you'll go to the opposite side, and then you'll switch from side to side, and you'll kind of like work your way in. And what's doing is it's starting to pull the center tight. Once the two ends starting to tighten up, it's going to pull the lagging, kind of dipping center in the middle super tight, and then you'll slowly work till you get to that middle point, and you'll iron it out, and it'll be nice and taut. And then that's how you apply the heat to your polyester fabric to get it nice and tight, and you'll be just like that old man that I told you about whenever I was in high school. Anytime that we select a material that we're going to use for any repair or any alteration that we're going to make for an aircraft, we have to select the appropriate material. Let's talk about the factors that determine how we choose the material that we're going to use for aircraft coverings. Now, your maintenance manual will have a lot to say about the standards that need to be met with any material that goes on the aircraft whatsoever. And the material that you choose to go with is going to dictate what type of tape, fasteners, glue, dope, you name it, comes with it, because they all have to be of the same brand, so that way we know that they adhere correctly. Now, there's other ways to kind of go about determining this. There are a host of like owners clubs, message boards, and the manufacturers themselves. You can, like, as long as the recommendations meet the standards put forth in the aircraft maintenance manuals, you can pretty well choose which one of those types of, which one of the brands, rather, really, go on the aircraft, be it Superflight or any number of the ones that we mentioned. The main thing is that you choose one that is, one, adheres to the maintenance manual, and number two is that whatever you choose, there's enough of it that you can purchase at the time to get on the aircraft, along with all the other parts and pieces that come with it. You can't pick and choose and be like, well, I want to use the tape for this one type of fabric, but this other I don't know, dope that goes with, or this glue that goes with this other type of fabric. They won't work together. The main thing is that you stay on brand no matter what. That being said, there is it's this is a typical like old man argument of like who has the better fabric for their airplane, and the reality of it is they're all probably minusculely different from one another, and that they, you know, even though that they're different, one of them might be better in a certain scenario than the other one. And so you gotta just have to do your research, talk to other aircraft owners, and let them know. If you're an A&P that's doing this for the for a customer, you sit them down and just like and have this conversation with them. It's like, hey, look, you know, like what brand of material do you want to go by? Maybe they don't have a preference and they're just outsourcing that to you. If that's the case, then you're going to go to the maintenance manual. Then you're going to go and start doing some market research to figure out which one's best fits best for your customer. If your customer has a passionate opinion on it, then you're going to sit down and say, okay, like, you know, let's see if we can get to yes with using that material in some way, shape, form, or fashion. But what we can't do is violate the maintenance manual on it whatsoever. So that's kind of how you're going to go about choosing the materials that you're going to do this job with. The basic stuff for just kind of like, you know, your boilerplate tool set of like brushes, paint guns, uh, you know, cleaning materials, that sort of thing. That's going to be a lot of that's going to be like kind of up to your preference, like of what you've used in the past and what works for you. Um, there, you know, isn't necessarily a one right uh, paint gun or paintbrush or, you know, drop cloth or whatever to use. You just need to make sure that you're comfortable and confident with whatever it is you go forward with, so, because that's going to dictate how good the final product is for your customer or your own airplane if it's your airplane that you're covering.